everybody, welcome back. What we're going to be doing in this video is a little bit of a interesting aside. So this is kind of the end of the class effectively. So we talked about all of the basics of Google Cloud, and there's so much more out there. And what I'm kind of challenging you all to do is to go out and find something cool that you can do in Google Cloud that I haven't talked about. And again, I didn't come close to scratching the surface. So I figured what we do today is, why the hell not? Let's play with quantum computing. This is something that we can do now with cloud services, right? You can do it with IBM. You can do it simulated in Python. We can do it in Google Cloud too. So I've got a little bit of a walkthrough for you, and I've got the link in the description. What we're going to be using a Google Cloud VM instance to basically simulate quantum computing. Now, caveat, massive, massive caveat, I am not a quantum computing expert, nor am I a programmer of it. I mean, I know how to write Python. I don't necessarily understand the ins and outs of quantum computing yet, but it's something that I'm kind of fascinated with. And we are actually at the point with our tools and technologies where we can actually play with the concepts of quantum computing. And if you are interested in kind of the future of the computing domain, it's probably worth at least getting a little bit of experience with it, I think. So what we're going to be doing here is creating a quantum computing instance. And now this is just going to be a normal compute engine instance. We are going to basically go ahead and create a kind of a bigger machine than normal. We need let's see, we need an N2 standard machine with 16 cores. So this is a pretty beefy machine, right? Look at this estimate, about 450 bucks per month to run. So make sure you shut this off immediately after you're done with it because your account will be emptied. But what this gives you is 16 virtual cores, 64 gigs of memory, and pretty beefy machine. And what we're going to be doing here is we are going to grab a container optimized OS. So we want this one. And hallelujah, it actually is the same version as the demo I'm looking at over here. Um, not always the case. Only need 10 gigs of data, that's fine. We want HTTP and HTTPS traffic, and let's go ahead and create this beast. Okay, so we have this machine spinning up. We're now going to connect it to Jupyter Notebooks, so something that we've done before with other services, but we are going to go ahead and do that. So we are going to need to do some port forwarding here. Ooh, what is the error? N2 CPUs exceeded. Oh, I did it in the wrong region. Okay. That's a good error to understand. So let's get, you are frozen. Okay. I don't know if it's just me or Google Cloud, but it seems to be acting wonkier than usual lately for the interface. Like sometimes I'll just get this little spinner going forever. All right, so let's delete you, dismiss. Okay, so no VMs. Try again. Seriously, what's going on here? Yeah, I know that's fine. Cancel. Close. Request failed. Wow, I've broken Google. Awesome. All right, let's go back to the home page. Maybe we're stuck. Stuck in a loop of re um, bad redirects. Okay, compute. And create instance. Let's be very careful with the region we pick. I didn't realize that was going to be an issue. I'm going to leave that in just so that you're aware of that. US East 4, 4C. So the reason why I didn't care about Central, I'm reading over here kind of the guide on quantum computing in Google Cloud. Although your selection isn't important, it might account for latency and availability. So I guess the availability was the thing that we have to worry about. And two, standard 16, we want a containerized OS. Might just be running really slow. Possibility too. Oh, all right. So we are back. I'm not sure what's going on with my internet here, but things are happening apparently behind under the hood. So 16 CPU, 64 gigs of memory. We want a container optimized OS. Okay, 10 gigs. Open up HTTP and HTTPS. Go ahead and create. We should be good now. So that's going to spin up. Assuming that works, life should be good. So while that's running, let's go ahead and you're not available either. Limit 8. Okay, let's try it with 8 and 2. Might just run slower. Compute optimized. Yeah, let's try it with 8, see how that works. Let's do US East. Container optimized. Allow. Okay, 221 a month, so still not cheap. All right, we'll let this spin up, and what we're going to do after that is up and running, hopefully we don't see that little red X of death, we're going to SSH in through the Cloud Shell, and we're going to connect via port forwarding. So we're going to go in through 8888. And it's going to be containerized too. So we're actually going to pull a Docker container off the gcr.io registry. It's going to be specific to quantum computing. Basically, it's just a Jupyter notebook that's been configured for our needs. Hey, it worked. Hot diggity. So we want to SSH in. So this is instance-1. So gcloud compute SSH instance 1 dash 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 L 8888 local host 8888. No. I hit no because it asked, are you sure you want US Central 1B? I said, no, I'm in US East 4. Thank you very much. What we should see once this is done is we should get a, so we are now in our engine here. The guide shows, well, hello at qsim-1. That'd be if we named our instance qsim-1. We called it instance-1 out of sheer laziness. So we see, so let's check home very quickly. So it's just home Eric Fredericks. Okay. Docker run -v backtick pwd home directory. Okay. Let's just do pw. Okay, so pwd. These backticks are interesting. pwd. Home Eric Fredericks. That's not sure why they have this in here. So Docker run -v pwd. We'll just run it right here. -p 8888-a.8888 gcr.io/quantum builds/github.com/ more typing. Oh God, I should have just copy and pasted this. github.com/quantum lib/Jupyter qsim latest. Unable to find image. Okay, so pulling it down. Again, we're pulling down the Docker registry. And I'm already in my home directory, so I'm skipping the pwd/home directory. I just went pwd. Right, so you're going to pull down and run. We are going to see hopefully a Docker URL that we can run. Okay. So we see things happening. Our notebook is being served. And it says to copy this last one here, and we're going to replace 127.0.0.1 with localhost. So let's save this off because I'm guessing we have to actually copy and paste it in later. Right, so we have a VM running Docker with Jupyter going. All right, so in a web browser, open the Get Started with QSIM notebook. Ah, okay. Sorry, I'm kind of running through. It's been about a solid month since I've run through this lab. So they also have you connect to Colab, which is basically a collaborative Jupyter notebook. So I'm just kind of dinking around with localhost, trying to actually access it like a website. But what we want to do here is we want to, let's see, open that notebook. After it loads, click connect. Connect. Oops, I want to connect to local runtime. Okay, we'll see how choppy this video is. Our local host is this guy. Connect. See if that worked. Okay. Unable to connect to runtime. Let's try this one more time. Okay. No idea what happened. So I copy and pasted the command as specified. It said it did not work. I refreshed it and we have something running. So, and according to this looks like it's running where it needs to be running. I don't know. Might be just me being overly ambitious with actually going here, but hey, we have a collab up and running. So this is what I'll show you. Basically, what we're going to do here is let's open up, or let's check out some of these simulations here. So again, I'm not a quantum simulation type of person, but there are Python libraries for it. So we can define qubits, define a short circuit. We can sample, quantum computing based circuits. If you want to play with these and kind of learn and understand it, I would definitely recommend checking it out. Let's go ahead and run. So we are installing the libraries. And since this is Python based, you can actually install this on your local machine too. I'm just kind of doing it through Google Cloud to kind of justify doing it in Google Cloud. Yeah, we're already at about 15 minutes of me kind of waffling on what's going on here. I kind of like that we're actually getting performance indicators up here. That's still going. I'll be back once this is done installing. So we have installed our Python libraries, and I'm not going to go through these because, again, I'm just kind of fascinated with the ability to actually run the code. I need myself to go ahead and learn how quantum computing works. So maybe in the future I'll run a class on it, but we have, hopefully, some circuits here. Hey, look at that, a quantum computing circuit. We can get some samples. Control Shift Enter, I think it was. Just Control Enter. All right, so we have some quantumness happening here. Let's play with qubits. Hey, we have some circuits. Multiple measurements. And this might not be the deep dive into quantum computing that you're looking for. But again, it's kind of a new field for me, and I'm just pleased to be able to run the code itself. So where would you take this? And, obviously we would kind of dig into what all of this type of stuff is, but in theory, if we figure out how to build the quantum circuits that we are trying to kind of simulate here, assuming we had the hardware resources available to us, you could take, if not the code, but at least the circuits that you're building and kind of deploy them on real world hardware. I know that you can reserve time on, at least IBM's got publicly available quantum circuits. I'm not sure if Google's made theirs available yet. The whole quantum supremacy thing is still an ongoing thing. But we have quantum circuits actually running in a Jupyter notebook, which is the easiest way to get up and running with something like this. So let's make sure that there's nothing else to talk about here. We can also just run it directly if we want. Just run a circuit, I think. I don't know if that's in here or not. Let's add a new block of code. Yeah, so we have some quantum stuff happening. All right, that's all I'm going to go into here. Again, brand new area. Definitely worth checking out if it's something that interests you. I'm going to go ahead and get rid of this VM right away before it drains my account. But hope this was interesting to you, interesting to me at least. I will see you all in the wrap-up video. Bye, everybody.